Hello, good day. We're going to study measurements in epidemiology in this lecture. And we're going to cover the two different ways in which epidemiologists do measure things. The two main ways in epidemiologists measure health states or disease conditions or indeed health conditions are measurements of the occurrence of diseases and measurements of the associations between exposures and outcomes. So the overview goes like this, that we're going to have the understanding of an occurrence of the measurements of the measurements of the occurrence of diseases in the form of measurements of prevalence and incidence. And then we're going to study the measurements of the association between exposure and outcome in the form of relative risk and odds ratio calculations. So we're going to cover things like the estimation of prevalence, the calculation of prevalence. We're going to take a look at things like person time, the concepts of person time. We will be covering age specific incidence and age specific prevalence. We will then study the the mathematics and tools of age standardization, the concept of age standardization, and where age standardization is used. At that point, we will be focusing on the association of the measures of association. This will include the measurements of relative risk, odds ratios, attributable risk, and we will finish this lecture with an understanding of the population attributable fraction and the intuition behind it. So, measurements in epidemiology, basically, why do people do measurements? Because that's fundamental to understanding any practice that we do. So, without a proper measurement, you do not know what to think of um, your things. So, to reinforce, there are two basic types of measurements that we normally do in epidemiology: the measurements of the occurrence of diseases and measurements of the association between an exposure and an outcome. So, in terms of the measurements of occurrence of disease, we talk about prevalence and incidence. And then, in terms of association between exposure and outcome, we are going to talk about relative risk and odds ratio. So, what is prevalence? Prevalence, think of prevalence as a proportion. So, here is a formula presented for you. On the left hand side, you can see the letter P. P stands for prevalence. P can also stand for proportion. Then on the right hand side of the equation, we see that there is X. X stands for the number of people with a particular health condition or a disease condition. And that number is divided by N, which means the total number of people um, from whom those disease conditions or the health conditions arose. Then there is a multiplication sign. And next to the multiplication sign, we see the number 10,000. And our 10,000 is also called a base. Base is this, that sometimes we need to standardize the presentation of the prevalence to a particular number. And in this case, we are fixing the number as 10,000. So we will say that the prevalence of a disease condition D per 10,000 population. And a reason why we have to have a base number is because we want to make comparisons of prevalence across populations or across samples. So then we will be able to then make a statement that the prevalence of pneumonia in city A was 10 per 10,000 and the prevalence of pneumonia in city B was 15 per 10,000. And that way we know that the prevalence of pneumonia in city B was higher than the prevalence of pneumonia in city A. But if you just only had taken the raw numbers, then these numbers can deceive. So, for example, if you did not know the base population, or if you did not know the population from where these numbers of people who had the particular disease condition arose, then we can be misled. So, in order to prevent that kind of a misleading presentation of information, this is what we tend to do. Incidence, on the other hand, tells us a very different story. In case of incidence, the idea is the number of new cases of a particular health condition or a disease that occurs among people who did not yet have that condition and over a period of time. So we need to think in terms of not only the number of people in whom a new disease is occurring, but also over what period of time. So this brings us to the concept of person year and a concept of follow up. Imagine a population of 1,000 people in a particular precinct of a city. And imagine a disease condition such as pneumonia. In the beginning of the year, none of these 1,000 people had shown any sign of pneumonia, and therefore there was no case at all to be reported. But over time, say over 1 year, we see that there were like 15 cases of pneumonia reported. So those 1,000 people studied for 1 year would constitute a metric referred to as 1,000 person years. So in the box that is shown here, you can see that we were studying 1,000 people for 5 years, and that constitutes 5,000 person years. If you look at the x-axis, you see that there is an empty start time and there is an end 5 years time, because that's the time period through which we have studied these people. And you can see that on the y-axis there is no lower number presented, but on the y-axis, which represent persons, the upper end is 1,000. So this box represents 5,000 person years. And think of this box as a conceptual space where the number of cases occur. And so we are then going to represent 5,000 person years as the denominator and a number of new cases that occur as the numerator. And on that basis, we're going to calculate the incidence of the particular disease condition or the particular health state that we want to talk about. Now, both incidence and prevalence are important metrics for us to understand, because incidence gives us an idea of the force of a health condition that is developing in a population. Prevalence talks about the proportion or probability of the occurrence of a disease condition or a health condition in the population. But in any population, the composition of people is not homogeneous. There are people of different two sexes, different age groups, different socioeconomic status, and these varieties need to be taken into account. For example, in the upper panel of this presentation, you see that we have presented a table that has got 11 rows and 3 columns. The first row presents 3 columns or information of 3 columns, the age group, which represents the age band, and you can see that the age band in the first column ranges from 0 to 5 years of age to 60 years and above. In the second column, we have presented data on the incidence of asthma in population 1, and in the second column we have provided, or the third column, which happens to be a second variable, which where we have presented the incidence of asthma in population 2. So accordingly, the second column is referred to as asthma underscore 1, and the third column is referred to as asthma underscore 2. So the second column represents asthma in the first population. In the third column represents asthma in the second population. If you read across this table, you see that in the age group 0 to 5, the incidence of asthma in the first population is 10 per 1000 population. In population 2, the incidence of asthma is 15 per 1000 population. So you can say that for the 0 to 5-year age group, the, the incidence of asthma in the younger age group of 0 to 5 years is higher. And this condition is reversed in the year age group 5 to 9 years, where we see that the incidence of asthma is higher in the first population, lower in the second population. Then in the 10 to 14 years, you can again see that the population of asthma is higher in the first population, lower in the second population. And then again, in the younger, slightly older age groups, 20 to 24 years, for instance, the incidence of asthma in the first population is 10, whereas in the second population is 20, and so on and so forth. If you study this kind of a pattern or distribution, we see that this panel presents to us the age specific incidence of asthma in each of the two populations. And then if you take a look at the lower panel, you see that this has been graphically present in the form of two bar plots. And you can see that there is a difference in the pattern of the appearance of asthma in the two populations. But the question remains, and the question is, we do get to see that there is a difference in the pattern of the occurrence of asthma in the two populations, but it does not provide us with any information in terms of what is the overall, or how overall are we able to understand the presence of asthma in these two populations. So one way, of course, is this, that if we sum up the population structures, in other words, how many people in each group, and then we sum them up and get a crude measure of the incidence, we can probably get some idea of this. But that is only a crude um, incidence in this case. That crude incidence hides a lot of the information that the specific age groups were varying with each other. So, is there a way in which we can account for the variation of the asthma in each of these age groups and can still get a way to take a look at these two numbers and say that, oh, certainly after accounting for the age difference or patterns of age, um, age-based populations, we can make a statement about in which population asthma was higher and in which population asthma was lower? The answer is yes. And the way to do that is to use a metric referred to as standardized health, standardized incidence or standardized prevalence if the measurement is prevalence. So in this graph or in this presentation, we are going to take a look at how standardization is done. Now, in order to do standardization metrics, we take the incidence in both population groups. So you can see that the age group of 0 to 5, 5 to 9, 10 to 14, and so on and so forth is presented. And then on the second column, we see that the incidence of asthma in population 1. In the third column, we're showing the incidence of asthma in population 2. Then in the fourth column, we have presented a standard population. Now, this standard population is anything that you can make up. The exact standard population does not matter, although there have been framing of standard population by the World Health Organization, by the National Cancer Institute of the